Yesterday we have seen the colloid chapter, and today we'll see the next chapter from your physical pharmacy. That is a surface tension and interfacial phenomena. And this chapter is again very important for your GPAT Niper and other exams. So as like that of the rheology. Rheology, micromagnetics, surface tension, interfacial phenomena, colloids, they are the very important chapters. So today we'll see this surface tension, interfacial phenomena. Now this chapter again I'm going to discuss two times. So today I will discuss the chapter from GPAT point of view. Tomorrow I will take a thorough chapter from your book. Okay? So tomorrow I will explain thoroughly all the things. Today just only what is important for GPAT that will be discussed over here. Right? So first of all, what do you mean by surface and what do you mean by interface? There are two terms which are very important. You have to understand what do you mean by surface, what do you mean by interface. So suppose that I have a table. If there is a table, this table is in a air. So surrounding this table there is air. Surrounding this table there is a air, and this is a solid. So surface. Surface is nothing but the boundary between two phases. The boundary between two phases. But if it is a boundary between air and solid, अगर एक फेज सॉलिड है एक फेज आपका गैसियस है, if there is a gaseous phase, if there is a solid phase, now they will, if say for example your foam, so in the foam also you have liquid and gaseous phase. Okay, okay, solid and air, so here also existence of interface, sorry, there is also existence of surface. So surface, that is nothing but a boundary between two phases. Particularly one phase is a solid and one is a either a gas. Okay, one phase is solid and one is a gas. So the boundary between solid and gas, or the boundary between liquid and gas, is known as a surface. Now the boundary, the minute boundary between two liquids, if it is not completely miscible, अगर दो लिक्विड है वो completely miscible नहीं है, जैसे अगर वाटर इथेनॉल डालते हैं, so water and ethanol, so there is no boundary between water and ethanol because they are totally mixed. Okay? They are, because ethanol is soluble in the water, so you will not found a boundary between ethanol and water. But definitely if you add benzene in the water, then you will clearly see there are two phases, because one is organic phase, one is aqueous phase. Now between this organic and aqueous phase, so there is a minute boundary. This boundary is known as interface. यहाँ पे दो चीजें समझना है आपको कि सरफेस किसके बीच में होता है. सरफेस होता है आपका, है ना, एयर सॉलिड, ये दोनों के बीच में जो होता है उसको अपन सरफेस बोलेंगे. एयर लिक्विड, उसके बीच में जो होता है वो सरफेस है. द बाउंड्री बिटवीन एयर लिक्विड and air or solid, that is the surface, and the boundary between two immiscible liquid, that is nothing but the interface. Surface and interface. Now surface tension, it is nothing but the force that occurs at a surface, surface tension, and interfacial phenomena. Right? So I have told you what is meant by surface and what is meant by interface. So boundary between solid and liquid is known as an interface. Boundary between solid and liquid is known as interface. Boundary between solid and gas is known as surface. Boundary between, a small boundary between solid and liquid, or liquid is known as interface. And boundary between solid and gas, or liquid or gas, is known as a surface. There is no interface between two gas. अगर आपने दो gases का mixture ले लिया, if you take a mixture of two gases, so they are completely miscible, so there is no boundary. If you take a mixture completely miscible liquids, say for example alcohol and water, there is no boundary. Okay, there is no interface, but interface exists when two immiscible liquids are there. Suppose if you pour a oil in the water, there is an interface. If you pour a benzene in water, there is an interface. So remember surface and interface. Surface is nothing but the small boundary that occurs between a gaseous phase and a solid, और a gaseous phase and liquid. तो गैस लिक्विड में, गैस सॉलिड में क्या होगा, सरफेस रहेगा. नाउ बिटवीन टू इमिसिबल लिक्विड्स देयर इज इंटरफेस, और if the phase, one phase is solid, one phase is liquid, so that is also interface. Remember these two things, okay? Surface and interface. Now what do you mean by surface tension? So surface tension is nothing but the force per unit length that is experienced by molecules which are on a surface, molecules of a liquid which are on a surface. से फॉर एग्जांपल आपके पास में क्या है, एक बीकर है, इसमें क्या है, लिक्विड है. Whatever liquid is there in this beaker, that liquid, that molecules of liquid, molecules of that liquid, so these molecules they are known as a, they are present in the bulk of liquid. So यहाँ पे एक molecule है, it is present in the bulk of liquid. Now this molecule experience a force, attractive force from all direction, okay, from all direction, from above, from below. So it will experience a force from all direction. Now suppose that some molecules they are at a surface. Now the molecule which is over here, so it will only experience force from nearby molecules and from downward molecules, right? So right, so there is a less force here, there is a less force, so force or the that is present on the molecules which are present on the surface of the liquid in a which is in an intimate contact with the air or your gaseous state, so they will experience little bit less force, they will experience little bit different inward pull, okay? So जो bulk में molecule है, that is attracted by all the sides, that is attracted equally from all the dimensions. If the molecules are in a bulk, now those molecules which are at a surface, they are only attracted by downward, okay? Now the downward pull is nothing but the downward pull is nothing but the surface tension, okay? So now surface tension, electrolytes they will slightly increase the surface tension. So if you add electrolytes, they will increase the surface tension. Whereas surfactant means what? Surfactants means surface active agent. Now, what is surface active agent? Why they are known as surface active agent? Because they are active on a surface only. So when you add a surfactant to a liquid, so these surfactants they get adsorbed at the interface. अगर यहाँ पे दो liquids है, if two liquid are immiscible, so there is just interface, वहाँ पे interface होता है. अगर दो liquid है, जैसे मान लीजिए ऑयल एंड वाटर, वहाँ पे जैसे नीचे वाटर है, ऊपर ऑयल है, उसके बीच में एक बाउंड्री रहता है, दैट इज नोन एज इंटरफेस. Now if you add a surfactant over here, surfactant will go at an interface initially. Few molecules of surfactant they get they used to get at an interface. कुछ molecule जो है surfactant के interface के ऊपर जाते हैं या फिर surface के ऊपर act होते हैं. That's why ना बाकी के individual molecule रहते हैं bulk of liquid में, right? So that's why they are known as surface active agent. Why? Because they are active at a surface or interface. So they are known as a surface active agent or surfactants because they are active at a surface or interface, right? So electrolyte, when you add an electrolyte in the liquid, so there is a slightly increase in the surface tension. If you add a surfactant, so there is slightly decrease in the surface tension. Am I audible you? Am I audible you clearly? Okay. So remember, small amount of electrolyte will increase the surface tension and your surfactants will decrease the surface tension, right? Now why we are dealing with the surface tension, because this surface tension interfacial phenomena is observed in a various kind of your formulations, so like suspension, emulsion, okay? So syringeability of your liquid, etc, etc. So that's why. What is the effect of temperature on the surface tension? Remember, temperature will increase the surface tension. temperature will increase the surface tension. Why? Because if you increase the temperature, the kinetic energy of molecule will increase, and which will decrease the attractive forces between the molecules. अगर आपने टेम्परेचर इंक्रीज किया लिक्विड का तो उसका जो सरफेस टेंशन है वो बढ़ता है. क्यों? क्योंकि हीट अप्लाई किया मतलब क्या? सो वो काइनेटिक एनर्जी बढ़ाएगा मॉलिक्यूल्स का. काइनेटिक एनर्जी बढ़ाएगा, काइनेटिक एनर्जी ज़्यादा बढ़ गए तो अट्रैक्टिव फोर्सेस कम हो जाएंगे. व्हाट इज द यूनिट ऑफ सरफेस टेंशन? यूनिट ऑफ सरफेस टेंशन इन द CGS यूनिट इज नथिंग बट द डाइन सेंटीमीटर इनवर्स. CGS यूनिट होता है डाइन सेंटीमीटर इनवर्स. SI यूनिट होता है, SI यूनिट होता है न्यूटन मीटर इनवर्स. So what is the unit of surface tension in the CGS? It is nothing but the डाइन सेंटीमीटर इनवर्स, एंड SI यूनिट होता है आपका न्यूटन मीटर इनवर्स. राइट, याद रखना है. बाउंड्री सरफेस किसको बोलते हैं? इंटरफेस किसको बोलते हैं? Now you can see over here the thing. So consider this molecule, this water molecule which is at a in a bulk of liquid. ये जो water molecule है ये कहाँ पे है? bulk of liquid में. Right? So now the water molecule which is in a bulk of liquid, so that will experience the attractive forces from all direction. This will experience attractive forces from all direction equally. But now consider, okay, this is known as a water molecule in the bulk. So it will experience attractive forces from all sides, okay, nearby molecules. Again you can consider this molecule. This is also water molecule in the bulk of water. So it will also experience similar forces, okay, but equal from all directions. Now consider this water molecule which is at a surface. Consider this water molecule which is at a surface. Now whatever force of attraction is, ये जो surface के ऊपर molecule है वाटर का उसको कौन सा experience होता है? Which force is experienced by this water molecule? Right? So you can see जो sidewise forces है. So this force, so it is, you can say it is a nullified when, but यहाँ पे जो inward force है, so whatever water molecules are present in the bulk, so bulk molecule, say for example यहाँ पे कोई water molecule है, that will attract this molecule towards the this molecule. So that inward pull, because यहाँ इसके ऊपर क्या है? There is no water molecule, so there is air, so that's why this force is, it is not, this molecule is not attracted, this molecule is not pulled from all sides equally. So net pull on this molecule is downward pull. ये सिर्फ downward में ही attract हो रहा है. Right? The force, okay, the force directed at the interior of the medium means that there is an inward pull. Okay? Now this force is known as a surface tension. This force is known as a surface tension. Right? Methods for measurement of surface tension. इसके ऊपर क्वेश्चन आता है, very important. We are going to see these methods in detail tomorrow. Okay? Methods for determination of surface tension and interfacial tension. So simply what is important for GPAT and Niper, that okay? Tomorrow we'll see same chapter, full chapter from book. Okay, don't worry. Now there are different methods. First method is nothing but the capillary rise method. Second method is a tensiometer method. Third method is nothing but the bubble pressure method, or it is also not total bubble pressure method. Then fourth one is nothing but the drop weight method. Fifth one is known as a DMER ring method. DMER ring method. There is one more method, drop count method. Drop weight method एक होता है, drop count method एक होता है. So capillary rise method, then tensiometer method, bubble pressure method, drop weight method, drop count method, DMER ring method. तो ये इसके ऊपर क्वेश्चन आता है. This capillary rise method will give you most accurate result. Capillary rise method will give you most accurate result. These are the methods to measure the surface tension and interfacial tension. पहला मेथड है आपका capillary rise method. Right? So in the capillary rise, so obviously as the name indicate capillary rise, तो इसका नाम ही रखा है कैपिलरी राइज. Say for example, you have liquid in this tank, and you just insert a capillary over here. Capillary insert क्या है? So liquid will move inside the capillary. It will move inside the capillary, right? Right. So it is used to determine the surface tension only. This capillary rise method is only used to determine the surface tension only. So here इसका इतना हाइट है, द हाइट, ये हाइट, उसके बाद डेंसिटी ऑफ लिक्विड, तो इसके ऊपर एक डेरिवेशन मिलता है. द डेरिवेशन टुमारो विल सी. दैट इज अ कैपिलरी राइज मेथड. So it is used to measure the surface tension only, and it is not possible to measure the interfacial tension by using capillary rise method. ये जो कैपिलरी राइज मेथड होता है वो सिर्फ सरफेस टेंशन के लिए, सरफेस टेंशन मेजर करने के लिए, इंटरफेशियल टेंशन के लिए नहीं है. It gives accurate result as long as contact angle is zero. It gives accurate result as long as contact angle between water, between the liquid and capillary is zero. Contact angle जब तक zero है तब तक accurate result देगा. Second, Dunai ring method. Dunai ring method, इसके ऊपर 2-3 बार क्वेश्चन आ चुका है एटलीस्ट. इसको अपन बोलते हैं Dunai tensiometer, also known as Dunai tensiometer. It is used for measurement of surface as well as interfacial tension. दोनों के लिए होता है. It can measure surface as well as interfacial tension. तो क्वेश्चन इसके ऊपर क्या है? So surface and interfacial tension is proportional to the force required to detach platinum iridium ring. इसमें क्या है? रिंग होता है प्लेटिनम इरेडियम रिंग, वो अटैच होता है आपका डायल वहाँ पे डायलमीटर होता है. Now you have to insert that platinum iridium ring, at a surface or at a interface, and now you have to, the force required to remove this ring from the surface or from the interface, that is nothing but the your surface tension. Okay. Now surface and interfacial tension is proportional to the force required to detach platinum iridium ring immersed at the surface or interface. Now question आपको ऐसा आता है, platinum iridium ring is used in the following method for measurement of surface tension of liquid. So platinum iridium ring is nothing but the Dunai method. Dunai ring method. तो इसमें रिंग आ रहा है ना, Dunai ring method, platinum iridium ring is used in the Dunai ring method. Okay. A small quantity of liquid is sufficient to measure the surface tension. Contact angle of liquid to the ring must be zero. Contact angle जो liquid और रिंग का contact angle होता है वो zero होना चाहिए यहाँ पे, right? So Dunai ring method. पहला है capillary rise method, second है Dunai ring method. Third one is nothing but the drop weight and drop count method. ये अलग अलग. Drop weight method is different. Drop count method is different. So we are going to see these methods in the detail tomorrow. But before that, what is important for GPAT? You know, I'm going to. So capillary rise method most accurate होता है. Right? You have to remember this. And Dunai ring method, it is measurement of surface as well as interfacial tension. Capillary rise method only for surface tension. Only for surface tension. Dunai ring method, platinum iridium ring is there. Platinum iridium ring is there, which is immersed at a surface or at the interface, and force required to remove that is nothing but the surface tension. Drop weight or drop count method. So in this there is one instrument known as a stalo, no, stalgometer. Stalagometer. This is known as a stalagometer, and it is nothing but the drop weight method. Stalagometer is used in the drop weight method, and उसको drop weight बोलते हैं. That is also used for the measuring of both surface tension and interfacial tension. Drop count method मतलब क्या है? Say for example आपके इसमें एक specific volume है आपका पिपेट में, और नीचे क्या है, मतलब एक आपने एक specific volume है आपके बीकर में, say for example 10 ml, और उसमें का पिपेट कर लो, ड्रॉप एक ड्रॉप काउंट करो. से फॉर एग्जांपल एक इसमें कलेक्ट करो ड्रॉप 30 ड्रॉप्स या फिर अपना 50 ड्रॉप्स, उसको वेट करो. अब में उसका एक डेरिवेशन होता है So we'll see that derivation tomorrow. यहाँ पे सिर्फ आप methods याद रखो. Capillarized method is there, denoying method is there, drop weight drop count method is there, Wilme plate method is there. Wilme plate method. So used for measuring both surface as well as interfacial tension, and the method is also similar to denoying method. Okay? But here in this method, just replace that ring with the thin plate made from either glass or platinum. तो वेल में प्लेट मेथड, तो वो जो रिंग होता है डिनोई रिंग मेथड में, वो रिंग यहाँ पे प्लेट से रिप्लेस करना है आपको, प्लेट मेड फ्रॉम ग्लास और प्लेटिनम. So capillarized method, denoy ring method, drop weight drop count method, and वेल में प्लेट method. Remember, only capillarized method is only applicable for measurement of surface tension only. बाकी सभी मेथड क्या है, surface as well as interfacial tension. You can measure surface as well as interfacial tension by using these methods. So, surface tension maintains the liquid. Surface tension maintains the liquid to its minimum surface area. Surface tension of a liquid maintains a liquid to its minimum surface area. Surface free energy क्या होता है? It is nothing but the work required to increase the area of liquid by 1 square centimeter. And it is equal to surface tension, surface free energy. इसके भी क्वेश्चन आता है, what is surface free energy? Surface free energy is nothing but the work required to increase the area of liquid by 1 square centimeter. ये उसका डिटेल में कल देखेंगे. Now what is meant by HLB? HLB means hydrophilic lipophilic balance. Hydrophilic lipophilic balance. So first of all, what do you mean by surfactant? Surfactant is nothing but a molecule. Surfactant is nothing but the molecule containing both type of characters, hydrophilic characters as well as lipophilic characters. Surfactant is a molecule having both hydrophilic as well as lipophilic characters. So Griffith in 1920, Griffith एक साइंटिस्ट है, इन्होंने 1920 में, Griffith in 1920. So he studied the properties of surfactant. Surfactant means what? It is not a surface active agent. They are active at a surface. So they will reduce the surface tension. They will reduce the surface tension. Surfactant will reduce the surface tension. Some of them are also used as a solubilizer to enhance the solubility. Some of them are also used as emulsifying agent. Some of them are also used as a wetting agent to increase the wetting, to decrease the wetting angle, to enhance the wetting phenomenon. So जैसे for example talc जो होता है आपका, so it is a poorly weighted solid. talc में अगर water डालेंगे तो weighting poorly होता है. And if there is a poor weighting, so that may create a problem in the formulation. से आपको suspension बनाना है. Poor weighting, suspension properly नहीं बन सकता आपका. There should be a proper weighting. Then only you can formulate the suspension, emulsion or liquid. So HLB is nothing but the scale, arbitrary scale that gives extent of hydrophilic lipophilic balance. How much hydrophilic lipophilic balance is there in a molecule? And this system was proposed by Griffith in 1920. Hydrophilic. Okay. So as per this, higher the HLB value, अगर किसी का HLB value ज़्यादा है, okay, normally it is okay. So HLB scale is ranging from 0 to 20. Okay. HLB value is a arbitrary scale on which molecules they are rated, on which molecules they have given the number depending upon their chemical nature, whether it has a higher lipophilic nature or hydrophilic nature, based upon that. Okay. But it may be have more than that value also. HLB स्केल नॉर्मली 1 से लेके 20 नंबर तक होता है, बट वो उससे ज़्यादा भी हो सकता है. फॉर एग्जांपल जैसे आपका होता है सोडियम लाउरिल सल्फेट, उसका HLB होता है आपका 40, है ना. उसका ऊपर क्वेश्चन भी आ चुका है GPAT 2023. व्हाट इज द HLB वैल्यू ऑफ सोडियम लाउरिल सल्फेट? सोडियम लाउरिल सल्फेट का HLB वैल्यू लेता है 40. तो अगर HLB स्केल 20 तक है तो उसका वैल्यू 40 कैसे? ऑब्वियसली मोस्ट ऑफ द टाइम कंपाउंड का HLB वैल्यू within 20 होता है. That's why scale is given from 1 to 20. But some compounds they have more than that HLB value. So it's like your sodium lauryl sulfate as a 40. So higher the HLP value of surfactant, more will the हाइड्रोफिलिसिटी. इसके ऊपर क्वेश्चन आ चुका है ना. सिंपली अगर कोई कंपाउंड का HLP वैल्यू जैसे मान लीजिए, सो ए कंपाउंड ए has a HLP value of 20, compound B has a HLP value of compound B has a HLP value of 5. So this compound A is a lipophilic molecule. Compound B is a sorry, compound A is a hydrophilic molecule. So there is a polar characters over here. इसमें ज़्यादा polar character है. And this compound B is a lipophilic in nature. Lipophilic in nature. Right? यहाँ पे non-polar character है. So a compound higher will be the HLP value of surfactant, more will be the hydrophilicity, lower will be the value of HLP, higher will be the lipophilicity. तो इसके ऊपर क्वेश्चन आ चुका है. अगर if a surfactant has a higher HLP value, that means it is a hydrophilic, lipophilic, amphiphilic. ऐसा क्वेश्चन आता है. So higher HLP value means hydrophilic, lower HLP value means lipophilic. Right? Am I audible to you? This is surfactant. There are three types. Surfactant are of three types: anionic, cationic, ampolytic. Anionic, cationic, non-ionic, like that. So, for example, surfactant is span surfactant. So it is a sorbitol ester of sorbitol ester. So it is a lipophilic in nature. So इनका HLP value होता है 1.8 to 8.6. Now twins means इसके ऊपर क्वेश्चन आ चुका है. Twins. So they are the derivative of polyoxyethylene derivative. They are the hydrophilic in nature. They have higher HLP value. For example, ranging from 9.6 to 16.7. So those surfactant which have higher HLP value, they are the hydrophilic in nature. Those surfactant which has a less HLP value, they are lipophilic in nature. Right? You can see here HLP values of some surfactant. HLP values of some surfactant. तो सोडियम लॉरेल सल्फेट का HLP वैल्यू था 40. इसके ऊपर कम से कम 3-4 बार क्वेश्चन आ चुका है. एटलीस्ट 3 to 4 times क्वेश्चन हैज बीन आस्क्ड. लास्ट है GPAT 2023. इसके ऊपर 2 क्वेश्चन है. इसका क्वेश्चन ये था, व्हाट इज द HLP वैल्यू ऑफ सोडियम लॉरेल सल्फेट 40. उसका आंसर है, एंड वन ऑफ द फॉलोइंग सर्फेक्टेंट हैज द हाईएस्ट HLP वैल्यू. ऐसा भी एक क्वेश्चन है. उसका भी आंसर है सोडियम लॉरेल सल्फेट. So remember, sodium lauryl sulfate has a 40 HLP value. Potassium oleate that is a 20. इसके बाद में है ना सोडियम ओलिएट होता है, उसका 18 होता है. पोटेशियम ओलिएट कितना है 20. सोडियम ओलिएट ये नहीं है. सोडियम ओलिएट that is a 18, उसका 18 होता है. 18 सोडियम ओलिएट 18. ओलिक एसिड का HLP वैल्यू है 1. क्यों? क्योंकि ये पूरा ओलिक एसिड क्या है, इट इज ऑयल, इट इज लिपोफिलिक. सो ओलिक एसिड का HLP 1. सॉर्बिटान ट्राइस्टीरेट 2.0. ग्लिसरील मोनोस्टीरेट 3.8. जिलेटिन का HLP वैल्यू आ चुका है क्वेश्चन, इट इज 9.8. व्हाट इज द HLP वैल्यू ऑफ जिलेटिन 9.8. सोडियम ओलिएट ये तो बोलता हूँ यार, सोडियम ओलिएट इज 18. Twin 20, twin 80, 16.7, 15 respectively. So this is the HLP value of few surfactant. तो याद रखना है सोडियम लॉरेल सल्फेट 40 और ये this is the most commonly used surfactant. So whatever shampoos you are using, so in that shampoo whatever soaps are you are using, in that soaps this sodium lauryl sulfate is there. Sodium lauryl sulfate is a carcinogen also. You can see over here HLP values. इसके ऊपर बहुत बार क्वेश्चन आ चुके हैं. HLP value it is ranging from 1 to HLP value ranging from 1 to 20. It is an arbitrary scale. So 1 to 20 and middle point is nothing but the 10. So if a surfactant has a HLP value less than 10, so that means it is a lipophilic in nature. Less, okay, as the HLP value decreases, the lipophilicity will increase. Now those surfactants which are having HLP value between 10 to 20 they are known as a हाइड्रोफिलिक. अगर किसी सरफेक्टेंट का HLP वैल्यू 10 से लेकर 20 तक है तो वो उसको बोलेंगे अपन हाइड्रोफिलिक. किसी का अगर 1 से लेकर 10 तक है उसको बोलेंगे लिपोफिलिक. जैसे जैसे वैल्यू कम होते जाता है ना, इफ ए सरफेक्टेंट लिपोफिलिक सरफेक्टेंट वैल्यू ऑफ HLP डिक्रीजेस. अगर किसी का 1 है तो इट इज हाईली लिपोफिलिक से ओलिक एसिड. अगर किसी का वैल्यू बढ़ जा रहा है 10 के आगे बढ़ रहा है दैट मींस हाइड्रोफिलिसिटी इज आल्सो इंक्रीजिंग. दो बार क्वेश्चन आ चुका है. व्हाट इज द HLP वैल्यू फॉर एंटी फॉर्मिंग एजेंट. एंटी फॉर्मिंग एजेंट will have HLP of 1 to 3. Then what is the HLP value for OW emulsifier, oil in water emulsifier? So 3 to 8. 3 to 8. What is the HLP value of wetting agents and spreading agent? So wetting agent, spreading agent, so they will help to solubilize the material. They will increase the ease of application. Spreading agent. तो वेटिंग एजेंट स्प्रेडिंग एजेंट का HLP होता है 7 to 9. इसके ऊपर हर एक बार इसके ऊपर क्वेश्चन आ चुके हैं सबके ऊपर. व्हाट इज द HLP वैल्यू फॉर OW emulsifiers? तो दे विल हेल्प टू, है ना, OW emulsifier किसके लिए यूज होंगे? ऑब्वियसली टू फॉर्मुलेट द ऑयल इन वाटर emulsion. HLP value of OW emulsifier is nothing but the 8 to 16. Okay, HLP value of water and oil emulsifier, WO emulsifier, 3 to 8. What is the HLP value of detergent? GPAT में आ चुका है, 23 में भी आ चुका. Detergents will have HLP value in a range of, ऐसा ही क्वेश्चन है, 13 to 16 और ऑप्शन बी यही था. HLP value of detergent 13 to 16. So what is detergents? They are nothing but they are used to decrease the surface tension of the dirt and stains. And they will remove dirt and stain and they will cleanse it up. It is known as detergents. So आपका जो detergent आप यूज करते हो soap होगा, that is nothing but detergents. Now what is the HLP value for solubilizers? So 16 to 20. बहुत बार क्वेश्चन आ चुका है इसके ऊपर, याद रखना है आपको. एंटी फॉर्मिंग एजेंट 1 to 3, WO emulsifier 3 to 8, है ना, वेटिंग एंड स्प्रेडिंग एजेंट 7 to 9, OW emulsifier 18 to 16, detergent 13 to 16, and solubilizers 16 to 20. HLP values. Okay, there are different methods to calculate this HLP value depending upon the chemical nature of compound. कि compound कैसा है, chemical nature क्या है उसका, उसके ऊपर डिपेंड करता है कि उसके कैलकुलेशन कैसे करेंगे HLP value. So methods to calculate the HLP value, इसके ऊपर भी क्वेश्चन आता है. So first method is nothing but the Griffin's method for non-ionic surfactant. Griffin's method for non-ionic surfactant. So according to this method, HLP value can be calculated as HLP is equal to 20 into M, capital M H divided by M. तो MH क्या है? MH is nothing but the molecular mass of hydrophilic portion of the molecule. MH मतलब क्या है? Molecular mass of hydrophilic portion. And what is M? M is nothing but the molecular mass of whole molecule. तो molecular weight कितना है और molecular weight of hydrophilic portion कितना है, उसके बेसिस पे अपन HLP value कैलकुलेट कर सकते हैं उसका. So HLP value according to the Griffin's method. So 20 into MH divided by M. MH is nothing but the molecular mass of hydrophilic portion. M is nothing but the molecular mass of molecule. And this will give you a scale from 0 to 20. That is known as a Griffin scale. This scale. So HLP value 0 means what? Correspond to completely lipophilic molecule. HLP 0 जिसका है उसको बोलेंगे lipophilic molecule. HLP value of 20 correspond to completely hydrophilic molecule. अगर किसी का HLP value 0 है उसका मतलब ये lipophilic molecule है. किसी का HLP value 20 है उसका मतलब ये होता है कि वो हाइड्रोफिलिक मॉलिक्यूल है. राइट. सेकंड मेथड होता है फॉर नॉन आयोनिक सरफेक्टेंट. नॉन आयोनिक सरफेक्टेंट, आयोनिक सरफेक्टेंट है, नॉन आयोनिक सरफेक्टेंट whose hydrophilic portion is a polyoxyethylene. पहला तो मेथड है for non-ionic surfactant. Normally, grip with me. सेकंड मेथड है फॉर नॉन आयनिक सरफेक्टेंट हैविंग साइड चेन, जिसमें जो हाइड्रोफिलिक पोर्शन है वो अगर पॉलीइथॉक्सिलिन है, पॉलीऑक्सीथिलीन है. फॉर नॉन आयनिक सरफेक्टेंट whose hydrophilic portion is a polyoxyethylene, so HLB is calculated as a HLB is equal to E divided by 5. HLB is equal to E divided by 5. What is E? E is nothing but the percentage by weight of ethylene oxide. Then third method है for polyhydric alcohol fatty acid esters. Polyhydric alcohol fatty acid ester. ये क्वेश्चन आ चुका है इसके ऊपर. So for example like queen, span, glyceryl monostearate, sorbitol monooleate, है ना. मतलब जो फैटी एसिड जो है उसके एस्टर से पॉलीहाइड्रिक अल्कोहल फैटी एसिड एस्टर, तो उस टाइप के जो सरफेक्टेंट है उसके लिए ये फॉर्मूला है. So you can calculate the HLB value of the fatty acid ester containing polyhydric alcohol. So HLB is equal to 20. HLB is equal to 20. 1 minus S divided by A. What is S? S is nothing but the saponification number of ester. A is nothing but the acid number of fatty acid. ये जो फॉर्मूला है इसके ऊपर क्वेश्चन आ चुका है. So how you can calculate the formula for calculation of HLB value of twins and span, ऐसा क्वेश्चन था. Formula for calculation of HLB value of twins and span. HLB value of twins and span is calculated by using the formula. तो ऑप्शन में ये तीन चार फॉर्मूले थे. So remember, for esters of fatty acid, polyhydric alcohol, esters of fatty acid, so you have to apply this 20 into 1 minus S divided by A. This is the formula. What is S? यहाँ पे S क्या है? सैपोनिफिकेशन नंबर. अपने देखा है सैपोनिफिकेशन नंबर इसमें, है ना. मिलीग्राम ऑफ KOH required to saponify the milligram of KOH required to saponify the fatty acid, free fatty acid present in the 1 gram of fat. This is saponification number. अपने देखा है वो lipids में. A is nothing but the acid number. Acid number. A is nothing but the acid number. So HLB value, HLB calculation for polyhydric alcohol fatty acid ester containing surfactants. So 20 minus 1, 20 into 1 minus S divided by A. So अगर नॉन आयनिक सरफेक्टेंट है उसके लिए ये मेथड है 20 into mH divided by M. अगर नॉन आयनिक सरफेक्टेंट है, if non ionic surfactant is there but the hydrophilic portion is the polyoxyethylene, then you have to apply this formula. HLB is equal to E divided by E is nothing but the percentage of weight of ethylene oxide, right? For name materials, for materials such as beeswax and lanolin. So how to calculate the HLB value of lanolin and beeswax? So in this case it is not possible to obtain the saponification value of this beeswax and lanolin. HLB value is given by E plus P divided by 5. What is E? Is nothing but the percentage by weight of ethylene oxide. P is nothing but the percentage of weight by polyhydric alcohol. तो आपको इस मेथड के ऊपर बहुत सारे, तो ये तीन चार जो मेथड है उसके ऊपर क्वेश्चन आ चुके हैं. ये HLB स्केल के ऊपर बहुत बार क्वेश्चन आ चुके हैं. व्हाट इज द HLB वैल्यू रेंज फॉर एंटीफोमिक एजेंट, है ना. 1 to 3 कम से कम 2-3 बार पूछा है. डिटर्जेंट का पूछा है 2-3 बार. सोल्यूबलाइजर का पूछा है. OW एमल्सिफायर का पूछा है. तो ये आपको याद ही करना पड़ेगा. एंटीफोमिक एजेंट 1 to 3 लिपोफिलिक होता है. तो आपको वाटर इन ऑयल इमल्शन बनाना है. ऑयल का क्वांटिटी ज़्यादा है यहाँ पे, वाटर क्या है डिस्पर्स फेज है, उसके लिए WO एमल्सिफायर रहेगा. बाद में 3 to 8, पहले 1 to 3 याद रखो, बाद में 3 to 8 याद रखो. उसके बाद में वेटिंग एजेंट एंड स्प्रेडिंग एजेंट, है ना. वेटिंग एजेंट स्प्रेडिंग एजेंट क्या है 7 to 9. उसके बाद में आता है अभी यहाँ पे WO एमल्सिफायर हो गया. अभी यहाँ पे ऑयल इन वाटर एमल्सिफायर. सो 8 to 16. बाद में डिटर्जेंट्स टू रिमूव द ऑयल. डिटर्जेंट क्या करता है, सो इट विल डिक्रीज द सरफेस टेंशन बिटवीन द क्लॉथ एंड योर डर्ट and it will free that oil. Now that oil is converted into emulsion by emulsifying agent, and that's how it is removed. Now oil के धब्बे कैसे निकालेंगे? डिटर्जेंट तो ऐसे ही। सो उसका सर्फेक्टेंट का HLB स्केल क्या होता है? सो HLB स्केल ऑफ डिटर्जेंट्स 13 to 16, सोल्यूबलाइजर का होता है आपका 60 to 20. Different methods for calculation of HLB scale. HLB value of non-ionic surfactant is calculated by this method. HLB 20 into mH divided by m. For non-ionic surfactant having your हाइड्रोफिलिक एंड polyoxyethylene, अगर उसमें हाइड्रोफिलिक पार्ट polyoxyethylene, so HLB value is calculated by using E divided by 5. What is E? Percentage by weight of ethylene oxide. Then for polyhydric alcohol fatty acid esters, so HLB value is yes. Okay? HLB value is nothing but 20 into 1 minus S divided by A. S क्या है? सल्फोनेफिकेशन नंबर. A क्या है? Acid value. Then for material of which sufficient number cannot be obtained, for them HLP value is E plus P divided by is weight of ethylene. P is nothing but the polyhydric alcohol groups. Wait, are you getting? समझ रहे आपको? Method based upon the component of group. Another method है. Another method is there. इसके ऊपर भी क्वेश्चन आ चुका है. Method based upon the component group surfactant molecule. Assign the group number and then assign with the group number. मतलब हाइड्रोफिलिक ग्रुप है कि लिपोफिलिक ग्रुप है ना. जैसे फॉर एग्जांपल OH ग्रुप है, SO2H ग्रुप है, दे आर द हाइड्रोफिलिक ग्रुप. CH3 ग्रुप है ना, कोई मोइटी है CH3 CH2 CH2, वो लिपोफिलिक ग्रुप है. सो उसको आपको नंबर करना है. assign the number with the group number, and then HLB is equal to summation of hydrophilic groups and summation of lipophilic group number plus 7. क्राफ्ट पॉइंट क्या होता है? क्राफ्ट पॉइंट बहुत बार क्वेश्चन आ चुका है इसके ऊपर. क्राफ्ट पॉइंट इज नथिंग बट द also known as a craft temperature. Craft point for surfactant or craft temperature is also known as a craft point or critical micellar temperature. Now it is nothing but the minimum temperature at which surfactant will form a micelle. मैंने जब बोला कि surfactants जो है surface attribution when they are added, okay, they will be distributed at a interface or surface, and some molecules will be present in the bulk. But if you increase the concentration of surfactant, now what will happen? At a particular concentration there is a association of, or there is a formation of flocules, or there is a formation of micelle. Concentration बढ़ गया वो aggregation होता है उसका. There is an aggregation of this surfactant molecule in the bulk of liquid, and there is a formation of micelle. And the concentration at which there is a formation of micelle, that concentration is known as a critical micellar concentration, and the temperature at which this micelle formation starts known as a craft point. This is the minimum temperature at which surfactant form a micelle. Below the craft point, micelles cannot form. Now every surfactant has a polar as well as non-polar groups. So polar groups or polar is known as a hydrophilic head, and that hydrocarbon chain is known as a lipophilic tail. So when there is a micelle formation, when concentration of surfactant is increased, so there is a association of this surfactant molecule, and they will form a micelle like this. So in the micelle, so hydrophilic heads they will project outward, and lipophilic tails they will be directed inward. So this is nothing but the micelle. So इसका shape अलग अलग होता है. This is circular micelle. So micelle means what? There is an association or there is the aggregation of surfactant molecule in the bulk of liquid. When in the concentration at which there is a formation of micelle start known as a critical micellar concentration. Okay, and the temperature at which there is a formation of micelle known as a craft point. Am I audible to you? Audible आएगा? Now remember craft temperature is nothing but the point. The craft temperature is nothing, or craft point is, or craft point or craft temperature is nothing but the point of phase change. है ना, यहाँ पे क्या होता है, phase change होता है. So जैसे for example, below the craft point, below the craft point, so surfactant is a soluble. Below the craft point, surfactant क्या है, soluble है. इसके ऊपर क्वेश्चन आ चुका है GPAT 2022 में. Below the craft point, surfactant is soluble in the bulk of liquid, but at the craft point, it is starting of formation of mycelium. Mycelium is association, and that is a insolubility. So craft point is a temperature. It is a point of phase change below which surfactant remains a crystalline form, as this question आ चुका है. Even in the aqueous solution, question आ चुका है. The craft point is a point of phase change below which, below the craft point, surfactant will remain in a crystalline form, even in an aqueous solution. Now, surfactants in such a crystalline state will only solubilize and form a mycelium. Surfactant in such a crystalline state will only solubilize and form a mycelium. If another surfactant assists in overcoming the process, it keeps it crystallized. मतलब below the crop point वो क्रिस्टलाइन फॉर्म में रहता है एंड तभी माइसिली बना सकता है ना. कब, जब उसको जो attractive forces है, if another surfactant molecule assists in overcoming the process that keeps it in crystallized form, or if temperature increases, thus causing the entropy, we have a stronger force and encouraging the crystalline structure to break. मतलब क्या, क्राफ्ट पॉइंट के नीचे सरफेक्टेंट सोल्यूबल होता है, क्राफ्ट पॉइंट के ऊपर जब क्राफ्ट पॉइंट आता है तब सरफेक्टेंट इनसोल्यूबल होता है. Surfactants are usually composed of a hydrocarbon chain and a polar head. Increasing the chain length of hydrocarbon, which increases the craft temperature. जितना हाइड्रोकार्बन चेन बढ़ेगा, क्राफ्ट टेम्परेचर बढ़ेगा. ये जो हाइड्रोकार्बन चेन है ये बढ़ गया, क्राफ्ट टेम्परेचर बढ़ता है. इसके ऊपर भी क्वेश्चन आ चुका है. Increasing the length of hydrocarbon chain will increase the craft temperature because it will improve, it will enhance, it will increase van der Waals forces. कारण ज्यादा अगर हाइड्रोफिलिक टेल बनेगा तो ज्यादा हाइड्रोजन van der Waals फोर्सेस बढ़ जाएंगे ना, क्राफ्ट टेम्परेचर बढ़ जाएगा. आर यू गेटिंग, समझ रहा है आपको यहाँ पे? नहीं, आर यू गेटिंग और नॉट? ओके, एडसॉर्प्शन आइसोटोप वगैरह जो है ना वो भी चल लेंगे पर इसमें. ठीक है, एडसॉर्प्शन आइसोटोप वगैरह वो अपन कल देंगे. एडसॉर्प्शन आइसोटोप, बिकॉज यहाँ पे क्या होता है कि एडसॉर्प्शन मतलब क्या है, मतलब एडसॉर्प्शन मतलब adsorption of liquid or adsorption of gases on a solid to form a monolayer known as adsorption. Okay, and this phenomenon was first time observed by Langmuir, and after that Langmuir adsorption isotherm was developed. There are 5 types of adsorption isotherm. We'll see it tomorrow. So adsorption isotherm we'll see tomorrow. बस आज इतना याद रखो कि आपका सरफेस क्या होगा, क्रिटिकल सरफेस क्या होता है, इंटरफेशियल फिनोमेना क्या होता है, उसका मेथड्स कितना है, डीनोइरिंग मेथड, कैपिलराइज मेथड, ये अपन डिटेल में भी देखेंगे. इसके बाद में HLB स्केल क्या करो, एडसॉर्प्शन आइसोटोप बाद में देखेंगे. वेटिंग फिनोमेना एक इम्पोर्टेंट है, इसके ऊपर भी क्वेश्चन आता है, ये भी मैं आपको एक्सप्लेन करूँगा कल इनिशियल पार्ट में. बाद में अपन वही चैप्टर बुक में से भी देखेंगे.